Welcome to Talking Comfort Live, a video podcast where HVAC professionals go for fun, learning, and sharing, while exploring the world of mini splits, heat pumps, and the inverter technology that brings efficient comfort to our fascinating industry. We're looking for you to be a part of the show. If you have a question, whether it centers around application, installation, preventative maintenance, troubleshooting, a future technology, or anything we share on the show, send it our way by clicking the question mark icon to the right of your screen. And you'll also see the poll icon there as well. Now, on to Talking Comfort Live.
Welcome back, everyone. Thank you for joining us today. Daniel here. Justin is with me here, and James joining us again. And we have a very special guest joining us, Mr. Greg Brunts from the technical team. Just wave, Greg. If this is your first time joining us, we've covered on the last shows cold climate heating, electrification, and HVAC rating systems. All of the previous shows are on the YouTube channel at GREE Comfort. And today we'll be talking about dual fuel. So many scenarios and factors to discuss. We'll try to keep it short. But please submit your questions, comment on the stream, and we'll try to get to everything that fits our topic today. What types of questions we'll be answering? We've got tech guys and product guys and sales guys here with us. And so anything that applies to what we're talking about, please, ask us and we'll try to get there and answer your questions. So Justin?
Yeah, so our topic for today is dual fuel. So we're going to jump right into that. So first of all, we're going to start off by talking about a basic scenario involving a retrofit application with an existing gas furnace. Then we'll kind of just go around the horn here and talk through the steps we would take and the factors we would consider before ultimately determining which system we would recommend. And obviously, if you've ever seen the show before, we'll probably be talking a lot about load calculations, things like that, properly selecting equipment. The next, we'll talk specifically about the system that's currently installed and how it looks and things like that kind of factor into the decision. Then we'll talk about our recommendations from a performance standpoint. This isn't the old heat pump technology from 30 years ago. We'll be talking about the new inverter technology like we usually do. And then lastly, we'll probably start discussing from a cost standpoint what you should do, either from the cost of the equipment, installation cost, operation efficiencies, utility costs, so on and so forth. So James, you want to introduce our poll questions?
So on our poll today, question 1, and if you take a look, you can click on the icon to the right of the webcast, but you can also scan the QR code and answer these polls for us. We do appreciate it when you do that. Question 1 is: does dual fuel still make sense considering the performance of today's cold climate heat pumps? Please, share your comments. The answers there are always, usually, about half the time, seldom or never. And then the question number 2 is: what are the top 3 factors you consider when determining a solution for a retrofit application? Do you consider system compatibility, energy efficiency, cost effectiveness, load capacity, the existing energy source, the installation complexity, durability and reliability, or homeowner preferences? So what would you consider to be the top 3 when determining a solution for a retrofit application? We are very interested to hear your answers, and we will get back to your results later in the show.
Thank you, James. Let's introduce our scenario with an existing furnace. Let's say, for instance, I have a 3-ton air conditioner with a furnace, and I need to replace the system. What are the things that I should consider to begin with?
So, my thought process in that, if you're taking a home that you go there and it's got an older gas furnace and a just a central air conditioner, in today's world, of inverter technology, it just makes sense to, either keep that gas furnace or change it to all electric, either way. But there's no reason why we can't keep a gas furnace in the house, but add a heat pump into that system, because now that homeowner or that customer is gaining another heat source, and it's not that much more difficult to do it in dual fuel, especially in the last, I don't know, 20 years. We've gotten rid of dual fuel kits. You got dual fuel capable thermostats. There's a lot of reasons why it's just so much simpler nowadays.
Right. And, if I could add to that, I know we're talking about this a lot, but, like the load calculations that Daniel had brought up, we've all been on job sites where the installation wasn't that great. And, you're there to replace the system. And if you don't trust the work that they did, why would you trust their math? Right. And we know that when we're talking about gas furnaces, they're offered in chunk capacities, basically. Sometimes the smallest furnace that you can get is far and away more capacity than what your house would require, right? And so that's obviously something to consider. Do you just replace it with the same type of would you try to use the largest heat pump that you've got, or are you going to do the heat load calculation, figure out what your heat loss is going to be at your design temperature to determine if this is going to be the right heat pump application for that job.
And another thought that just came to my mind, like if you go into a house that's got an 80% furnace and the customer's wanting to increase in efficiency. So now to do that with a gas furnace, you're going to be getting away from metal flue. You're going to have to go to PVC piping to, put the flue on that furnace to get up in efficiency. So therefore, now that brings in other factors, whether a water heater and furnace share that same flue. So now would you have a flue possibly that's oversized to leave just the water heater on it? So what I'm getting at is there's multiple reasons there that it may make more sense to go back with another 80% furnace, maybe using a two-stage 80% furnace, for example, and adding a heat pump to it. So now you've done exactly that for that customer. You have given them increased efficiency, because there's a lot of that winter where that heat pump's going to work very well and very likely to be more efficient than running that gas furnace, especially depending on what fuel it's on. But even on natural gas, if you're talking zero above, it's a good possibility that heat pump's going to be running a whole lot more efficient than running that 80% gas furnace. And you've effectively given that customer what they're looking for without having to add in more flue pipes, which is not always easy to do, depending on how the layout of that home and stuff like that. It's not always easy to get PVC pipe in the right place and functional. And then you also have, like I said, mentioned about the other, sharing a flue with a water heater or something like that. So it just gives us one more tool to be able to give the customer what they want, but minimize the impact on what it takes to actually install it.
Right. So, like you're saying, you might have a job where you're having to consider additional roof penetration and, things like that, right? Like if you did go to 90%.
Yeah. Whether you go through the roof or you go through a sidewall termination,
yeah.
But, in a lot of homes, you go into them, many people have finished basements and stuff like that. Trying to get them flue pipes in is not always easy to do. And then you also have to have clearances to windows and gas meter and many other things, which all of that you don't have to worry about anymore if you're going back with another 80% furnace and you're just adding a heat pump to go with it.
Yeah, especially, I guess, particularly if the house is built around, using something like that, you've already probably got a chase and, all the rest of that, it's kind of already there.
Correct.
Things you don't have to do would be cheaper. Right.
It would, in my opinion, it would be cheaper and it'd be a faster installation to add a heat pump and go back with an 80% furnace than it would be to, up that furnace in efficiency and include all the PVC piping and everything, and then along with a new air conditioner or heat pump, whatever you put with it.
And then another thing to take into consideration would be what fossil fuel are they using? Do they have LP? Do they have oil? Or do they have natural gas? And the cost considerations there. We were talking earlier and had some really good points on that. You want to share those, Greg?
Yeah, I mean, so the other things to keep in mind here is, and I've been doing this for a long time, I've in most applications, or a lot of applications, I should say, furnaces are notoriously grossly oversized. So that's where we come back to the load calculation. Do you really need a furnace that big? And is a heat pump not going to give you what you want? Because chances are that heat pump or that gas furnace was oversized from the get-go.
Right.
And then the customer dealt with temperature swings and stuff like that. It still worked, but that's another thing we gain from inverter-driven heat pumps is you get longer run times. But with the inverter-driven heat pumps, the complaint always been with heat pumps is that it feels cold coming out of the register. With inverter-driven heat pumps, we keep that supply temperature up very close to gas furnaces in a lot of instances, so they don't feel that no more. So, without them not getting that cool air sensation that has always been a big complaint with heat pumps, now we're able to do it with a heat pump that's giving them that warm air, and just like they were accustomed to with their gas furnace. But on the same token, we're doing it at lower amp draw, lower run of the compressor, maintaining that temperature in that house, which gives that house a more even and warm temperature feel compared to a gas furnace that comes on, satisfies the thermostat rather quickly, shuts back off, falls below that temperature, and then while we're warming the house right back up again, and you get in these temperature swings that have always been a complaint with consumers. They just got used to it, so they don't know to complain about it anymore.
Well, so to put you on the spot here, Greg, but you've got more gas experience than I do. But I've always wondered why, if I take like a 5-ton drive, why my option for furnaces is like 120,000 BTUs. I mean, to me, I'm going, okay, I got 60,000 BTUs worth of coolant available to me, right, in the summer. But then all of a sudden I need 10 tons worth of heat, in the winter. Like, I guess, maybe it made more sense when the furnaces were far less efficient and you weren't getting the 120 grand worth of BTUs. But, now, especially with 95, 96%, furnaces, it just, can you maybe expand on why that might be?
Well, I think a lot of that comes back to the drive you need in that furnace to be able to handle a 5-ton air conditioner. I mean, because the industry standard, and a lot of people refer to, is roughly 400 CFM per ton. Well, to get 400 CFM per ton, you're going to have to go to a larger furnace cabinet, so we can have a bigger blower in there to be able to push that kind of air. And that's the other good thing about inverter-driven equipment, is we don't necessarily got to meet those airflow requirements anymore. We don't necessarily got to be pushing 400 CFM per ton. Many of our inverter-driven systems work very well at 325, maybe 350 CFM per ton. So now we can lessen the impact of the size of that, and the cabinet size on the indoor unit.
Right. Well, I guess too that when we're talking about BTUs, we're also talking about BTUs per hour. That's what we're saying, right? So 120,000 BTUs, that's how many BTUs it outputs in an hour. Well, if I run for 30 minutes out of that hour, I provided 60,000 BTUs to that space, right?
Well, and that falls back to, though, again, like I was saying, many furnaces out there are grossly oversized, and then to your point, with 5 ton, they're having to go to 120,000 BTU furnace. Doesn't mean they need 120,000 BTUs. There's one good example of the furnace is oversized because we need that drive for that 5-ton air conditioner.
Right.
We don't necessarily need 120,000 BTUs of heat.
Right.
That's why that heat load calculation is so important. How many BTUs per hour do you need to satisfy the heat load of that structure?
Right. So, I mean, I guess the main takeaway would be not use the size of the furnace, to determine what size heat pump I might use.
No, no, they got to do a heat load because we need to know. Yeah, now we need to know, hey, what exactly does this structure need to properly heat it? And if they do need more than what one heat pump can deliver, that's not the end of the world either, because we can always go with 2 inverter driven units and get that BTU per hour that we need. And then you also got some redundancy built into that as well. In other words, you have, if one system goes down, you still have one system heating the house. You're not completely out.
Right. Right. I don't know if most people that are watching can tell, I don't live in a cold place, and I'm not really from a cold place. Neither is Daniel, for example, and I know Justin also is in a very cold place. But I know that, like, when we lose power, that kind of thing, especially in the dead of winter, it can take a while for the heat pump to it can take a while for the heat pump to catch up if if the power's been off, right? The nature of a heat pump. But in the dual fuel application like that, if you did lose power and it's negative 10 outside, hey, you got the 120,000 BTU furnace, you get 120,000 BTUs, and if it runs for an hour, you're probably going to catch up a lot faster. But I mean, one thing I'll also keep in mind is, setbacks and all that, make a lot more sense when you're talking about a system like that, right? Where you might be able to save money by, setting it back, in the, during the day, and then just turn it on when you get home, that kind of thing. They make more sense with traditional style systems, but with inverter driven systems, they generally don't, just keeping it, maintaining the temperature can actually be far more efficient than setting something back. Right.
Well, and the reason for that is the fact that, you're talking about burning a fuel
right
to heat the home versus a heat pump that is taking heat from one environment and discharging it into another environment.
Right.
Although it technically is more complicated, but we have efficiency within the equipment nowadays that we are able to reach them cold climates into them. We got heat outside to minus 460 degrees Fahrenheit. Now what becomes is whether or not it's effective to pull that heat is 2 different things. And
right.
But your old school heat pumps going back 15, 20 years ago, heat pumps lost efficiency or lost heat output dramatically as the temperature fell below 32 degrees. If you look at the expanded ratings on them heat pumps, the BTUs off of, say, a 3-ton heat pump, it may be, let's say, 0 to 10 degrees, you might be lucky getting 7,000 BTUs out of it.
Right.
Well, with our cold climate heat pumps, though, now these things are, at 0, you're still putting out 100% capacity. So it's a game changer when it comes to, when we talk about dual fuel and adding a heat pump, there's significant value there.
Right. And I know we're talking about 15 years ago, 20 years ago, or whatever on heat pumps. But I mean, I think one thing that we should keep in mind is that many of the heat pumps that are still on the market right now are based on those designs, and they still do lose efficiency starting at 47. I mean,
you're absolutely correct. Unfortunately, I overlooked that when I made my statement, but you're absolutely correct. No. Many of them still today are on that same design platform that they ain't really producing any better heat than they used to 15, 20 years ago when you start getting below 32 degrees.
Right. Well, I mean, like, I know that you can lose on a 4-ton heat pump, regular traditional style heat pump, you can lose 1 ton of heat from 47 to 36, depending on the manufacturer design and all that kind of stuff. But, we're still talking about, with traditional heat pumps, you can still make the argument that maybe it's not the answer for you. But, when you're talking cold climate, you're talking inverter driven, those are definitely a much better option than what heat pumps used to be.
Well, and it also brings up another thing that I've seen the mistake done many times, and it's become more important today than it ever has been before. That when you're sizing a system and you're looking at load calculations, we got to quit using the nominal capacity as our sizing. We really need to look at expanded ratings, because much of our equipment, it may be nominally rated for, let's say, 4 ton of cooling, but if you look at the heating output, it's much higher than that 4 ton of cooling. So, looking at expanded ratings and seeing what that equipment's actually capable of delivering, both in cooling mode and in heating mode, as you're picking the piece of equipment, is huge, instead of using nominal capacity.
So one thing I'll ask is, if you haven't done so already, please, scan the QR code and click the link to the right, and help us answer give your answers on the poll questions that we've got today. So you get an opportunity to do that. But we do have quite a few questions. We'll take this opportunity while you guys are absolutely doing the poll, right? We'll take this opportunity to go over some of those questions that have come up. So we do get asked pretty often about a downflow air handling unit. We do have a downflow kit on its way to the United States and North America in general, on its way right now for both our flex air handling models and our muti-pro air handling units. So that will be a viable option. As far as an exact date, I can't provide one of those right now. But they are definitely on the way, and we will notify you guys. And maybe we'll just have a whole podcast on downflow. How about that? I'm just joking, but that is on the way. So, okay. So here's a pretty common question that we do get. Can you install a 2-ton flex when you have your load calculation calling for 1.5 tons? Nobody?
Yes, you certainly can.
Yes, you certainly can. Right. You absolutely can. The minimum capacity is far less than 1.5 tons on that 2-ton, but it may also give you an opportunity to use the energy saving mode that's available on the Flex to better maybe provide better dehumidification, better cooling, better comfort on an application like that.
And if you have questions on, how to set that up, we put all those details in the quick start guide about setting your 1/2 ton sizes. And, like James said, using the energy saving mode, go ahead and put in that size and then drop it down 1/2 ton to match that perfectly. Okay. Let's keep moving forward, and we'll get back to the questions in a little while. So one comment that we had written from the poll is, I've been in HVAC for a long time and dabbled with heat pumps for the past 15 years. What changed in the tech that makes it work now in occasional negative temps? And we'd like to run video.
GREE Flex and muti-pro use ultra heat technology that makes the unit a true cold climate heat pump. These units use a 2-stage, 2-cylinder enhanced vapor injection inverter driven compressor that allows these units to heat effectively down to -22 degrees Fahrenheit. GREE Ultra units can go as low as -35 degrees Fahrenheit. The ultra heat compressor is a 3-pipe compressor. It has a suction inlet cylinder, mid-pressure jet, and your discharge. For the ultra heat compressor to achieve cold climate heating, the following components are needed: a gas liquid separator, the electromatic valve, and with those 2 components, that will allow refrigerant to flow through the electromatic valve into the mid-pressure jet of the compressor. Let me show you how this all works together. Here's the refrigerant flow diagram of the Flex unit with the ultra heat compressor. Normal refrigerant flow in heating mode. Hot gas refrigerant is discharged off the top of the compressor to the indoor coil, where heat is released into the indoor air. The refrigerant condenses back into a liquid and then flows to the secondary EEV. This will subcool the liquid some before it flows into the bottom of the gas liquid separator. The cool refrigerant will then flow from the bottom of the gas liquid separator to the primary EEV to flash refrigerant into the outdoor coil, where the refrigerant will boil off into a gas, while absorbing heat into the refrigerant. Then the refrigerant flows back to the compressor into the low pressure cylinder. In cold climate heating, the electromatic valve will open and allow refrigerant to flow from the top of the gas liquid separator through the solenoid into the mid-pressure jet into the high-pressure cylinder of the compressor, effectively compressing the refrigerant a second time and increasing the discharge gas temperature. Keep in mind, the main board in this unit uses information from the thermistors and the pressure sensor to determine when cold climate heating is needed and how often and how long the electromatic valve will be open. And this is what makes GREE simply the best in cold climate heating. With GREE, we are by your side.
Excellent video from our special guest, Greg, explaining how the new technology is working much better than the old technology. Talked about the inverter-driven compressor, how it can change speeds, how the outdoor fan can change speed, and more precisely control the refrigerant versus the old technology where you had a single-stage compressor running in one speed with just a piston metering device. That probably wasn't the most efficient, wasn't getting the best capacities out of it. So just based on that technology that Greg explained in the video with inverter compressors, that's really the big leap forward in the technology and what's changed. So again, we're not talking about the old style heat pumps. This is kind of how we achieve that heat. That's more on par with the furnace. What we're talking about with the dual fuel and whatnot. So let's go ahead and go to our poll question results. Poll question was dual fuel. Does it still make sense considering the performance of today's cold climate heat pumps? So we got about 37.5% said always, 12.5% said about half the time, and 50% said seldom. So I would assume maybe the people who've said always may live up in perhaps the Great White North with their sled dogs, and they need that that additional heat, perhaps, or maybe just in areas where the power grid isn't quite up to snuff yet. But for most of the United States, I think we can confidently say that, unless the natural gas or whatever you're burning is so cheap, that seldom does the dual fuel make sense. It's usually going to be much more efficient and much more cost effective and quite frankly safer to just run your straight heat pump. Question number 2, we asked, what are the top 3 factors you consider when determining a solution for retrofit application? And we have answers kind of all over the board here. Top answers being load capacity or heat load, energy efficiency, homeowner preferences. And it's kind of an even split between compatibility, cost effectiveness, existing energy source, and durability. Excellent. So you guys have any comments on the poll results?
Yeah, I like the fact that installation complexity is like the lowest one, because we're all experts, and complexity is not a problem for us at all. It's hard to disagree with this. Obviously all of these things are important. I think that's why we probably end up with a tie among quite a few of them. But yeah, I can understand where load capacity, would be a concern, especially when we're talking about like what we were just talking about with furnaces being so large. That's just kind of how I believe people got accustomed to sizing them, that kind of thing. And some of it just like what Greg said is like limitations based on the manufacturer of the furnace itself. You're limited on the drive.
Well, what I got out of all that is there's no one thing that is the 100% thing that we need to worry about. I like the response in that. What I'm saying is all these things are important when it comes to what you're going to do when retrofitting a new system. That we're looking at the whole picture there of what's best for that customer, and most efficient way to go.
Yeah, that's a great point. I know we say a lot on this show, when we're talking about the applications and everything, that it depends really. And, each application is unique. Each homeowner is different. So all these things can factor into the application and what solution you provide for that application. And some people may approach things differently. So like we said, it all depends on the factors, right? But I think one thing that I kind of want to bring up, and I don't think we probably talk about it enough on the show, and it really affects your load calculations and equipment sizing and all that, and efficiency, and that's weatherization. Having enough insulation in the house is a big factor, or making sure the home is sealed properly is also a big factor, because if you go in and you add additional insulation and you seal up all the outside air infiltration, to help prevent that heat loss, maybe where you needed a 5-ton heat pump, well, now you may only need a 3.5 or a 3-ton. And because you're not losing all that heat, through infiltration in the home, your system's going to be running a lot more efficiently just from avoiding the heat loss. And now, because you've lowered the size of your equipment, you're actually able to use less BTUs to heat the home. And so you're going to be using less electricity or less fuel to heat it, right? So I think as we talk about load calculations, all that stuff, I think it's very important. People also look at maybe blower door testing procedures, going through, checking it out, making sure you don't have a lot of leaks in the house, check the insulation, go up in the attic, measure it, see if they have enough. If not, offer a solution to blow more insulation in. I think that's a major issue in sizing and energy efficiency that, if we tackle that, it's overall better for the homeowner because they're getting the properly sized equipment they need. They're using less electricity. Because they use less electricity, now it's easier maybe to load up on the grid and things like that. So I think that's something that people should focus a little more on.
Justin, you bringing that up is kind of neat because, I wanted to expand on that a little bit, in that there's many municipalities or even cities and states and stuff now that are, and that's why I wanted to say this, because, a lot of you might think I'm a heating and air conditioning contractor. I'm not, whether or not their home's airtight is not really my issue. But and maybe you care, maybe you don't. That's not my point. Is that there's many municipalities, states, cities, and stuff like that that are starting to push that these things are done along with a new system being put in. In other words, they don't want to even give you a permit unless that house has been, or that structure has been weatherized, and that these requirements are being met to make sure the home is efficient to be heated and cooled. So I don't know if that's where you got that from, but that's where it is coming, and it may be coming into cities and towns and municipalities in your area. So it's something to be aware of that's coming around. So,
and that's a really good point, Greg. And to that point, I see a lot of contractors reaching out to us, HVAC contractors, that, in their company name, they'll have the term energy, or, it's HVAC and, and energy. And, that's a wonderful business opportunity there to match those two together, energy management and also HVAC.
Yeah, it's a great point to bring that up, especially because, as Greg mentioned, the code is changing, so more and more cities are requiring that blower door test. A lot of them already require the heat load calculation. So if you don't already know how to do heat load, great time to learn. Great time to learn to do the blower door test, because hopefully before too long, most states will require that. It's not trying to make things more difficult on people, but I think as we as professionals in the industry, we just need to make sure that we're out there, we're doing the right thing A, for the homeowner, and B, for, you know, for the energy grid and the environment and everything else. And all of these factors kind of tie into that. So, you know, very, very important. And we mentioned in prior shows where it's usually not people in the industry driving the changes. It's typically regulations. We usually like to wait for the government to come in and tell us what to do, because we don't do the right things on our own, right? And I kind of hate to admit that, but it's always the government driving the changes. So it's kind of funny that we bring that up. But going back to the dual fuel discussion and really kind of what determines whether or not we can go dual fuel or why we should do that, I think we kind of established that generally, unless you're just in an area that absolutely needs it because it's either so cold or the power grid just isn't there, that you don't really need dual fuel. It doesn't make a lot of sense in most areas. However, you know, there's a couple of factors that lead into determining that decision, right? And I think most of the time it's what is there. So if you go into a home and there's already a gas furnace, a lot of times people want to stick with that gas furnace because the homeowner likes the gas heat. They like that 10 tons of heat output that they can, you know, stand over a floor grill and warm their feet up in the morning, you know, things like that. So it's just usually people being uncomfortable with changing what's already there, for example. And, you know, I think another big issue with determining whether or not we should go dual fuel or all electric is the cost issue. So James, you want to talk about cost or the cost differences there?
Yeah, absolutely. So, I mean, obviously, with any kind of decision you make, there's going to be some payoff time, right? You know, and you know, I've heard everywhere I've gone, you know, people have said, "Oh, well, you know, my natural gas is cheap." You know, and I've had a lot of conversations about that. You know, I feel like natural gas wouldn't be nearly viewed as cost effective if you had a gas powered TV and a gas powered everything else in your house. But as far as like total energy usage, there are many areas where it no longer makes sense to do a dual fuel because of the, or at least from a cost standpoint, like an energy cost standpoint. However, you know, when you're trying to put a price on like backup and that kind of thing, it's kind of hard to, you know, put a price on that. But you know, I've never heard of well, I haven't heard any time recently where, you know, something was shot down as far as the price difference between going dual fuel or going straight heat pump. You know, the price difference between straight ACs and straight heat and heat pumps has closed significantly over the years. And, you know, the fact that there's not a whole lot of accessories and stuff that have to be added in order to do dual fuel like there used to be has really, you know, closed the gap on pricing on dual fuel. So, I mean, I think it's from an equipment standpoint, you know, there may be some cost difference, but like as Greg pointed out earlier, you know, depending on the house, depending on the job, you know, it could be more expensive to upgrade that furnace than it would be to not use the furnace at all. You know, it absolutely just depends on, you know, it's kind of job specific and like Justin brought up, you know, homeowner preferences too. Like if somebody likes to stand over the grill and get warmed up, well, you know, the heat pump may not be what they want, you know, but if they've got dual fuel, that may be something they, you know, would enjoy and be willing to pay for if there is a significant difference.
I think, in my opinion, the biggest application for dual fuel is gas furnaces. Gas furnace that needs to be replaced that is using propane for the fuel source, because that is, you know, the propane cost is not cheap no matter where you go in the United States, and they can get a significant of money saved in utilities by adding a heat pump along with a gas furnace.
Right.
Now, new construction coming right out of the gate, putting in dual fuel, I mean, if you have your, well, I'm doing it myself. I'm building a house in Tennessee myself. I had the option. I could have went with propane. I decided to go all electric because I'm really not going to gain much because of the efficiencies of a heat pump, other than that one-off thing that, okay, now I got two sources of heat. One would be fuel, and one would be electric. So, you know, could I have done it? Yeah, sure, I could have done it. But also, you have to factor in, okay, new construction. Do I really need to, you know, put in the propane tank, run fuel lines? All that adds expense that, you know, if propane's high enough now that I don't want to pay for the propane, I might as well just go all electric. So
Kind of.
again, it comes back to preferences too. You know, it's not always our decision; it's the homeowner's decision. They want that insurance, and you know, hey, I want to be able to have that gas furnace in case that heat pump quit working or something like that.
But
There's nothing wrong with that.
please feel free to remind them though that you do have to have the boiler operating in order for the furnace to work. So it doesn't mean it works when the power's off.
That's true. True.
So, kind of playing devil's advocate, I think a really good application for dual fuel are in those areas, you know, up north, maybe New England, where typically, you know, on a heat pump, like a GREE heat pump, you'd require an ultra heat compressor. But say, you know, it's an older classic home and the electrical service just isn't there. And it's going to cost a lot of money to bring in an electrician to upgrade the panel, you know, and fix all that. So there might be good applications for dual fuel where, you know, it's just more cost effective to go ahead and go back with, you know, a gas furnace in those applications, because they don't want to spend thousands of dollars upgrading the electrical service, right?
Yeah, because your power consumption difference between an air conditioner and a heat pump is minimal.
But if you're talking about the backup heat source, you know, like an electric heat kit versus gas furnace, there's
Right.
There's where that's where, like I was saying, with from what Justin was just saying, you might as well stay with the gas furnace. Now we don't have to upgrade electric panels or anything like that, but we can still, instead of going with an air conditioner, go with the heat pump, and there's little to no impact on the electric service to the structure.
And that kind of brings up we'll like to talk about as redundancy. I actually have an LP furnace, a package unit, as a mini split on my home, and you know, at any time that the power goes out or whatever happens, I can run my, you know, hook up some generator to the furnace and let it go. Or, you know, I'm never cold, I'm never hot. I always have a backup. If one system breaks down, I have something to go back to. So I love redundancy.
Yeah, I've got gas logs myself. I mean, I'm all electric, you know, as far as my heating and cooling goes. But I do have a set of gas logs, and you know, when the power has gone out, well, I don't need power for those. You know, I do need to remember to turn them off. That's the only downside. You know?
Well, some of us are still capable of chopping wood and building a real fire.
Well, I don't know why. I guess if you're chopping the wood, then you don't need that much heat because you're working up a sweat. So
there you go. I got two gains, two sources.
Fortunately, I'm in Dallas. There aren't too many trees around to cut down.
Although wood heat is popular here, which is kind of, you know, ironic, but I think it's more of an aesthetic thing, right? No trees. You're sitting on top of gas, but they're using wood. Yeah, it's, I don't know, it's funny.
Yeah, they can drive to Home Depot and in their big trucks and load up on lots of wood, right? Drive it back to their house.
Yeah. Where I'm from originally in Alabama, there's all the trees that you could ever want. Nobody wanted to burn wood. You know, so they'd be, you know, bringing in the gas via pipeline. It's just, you know. Looks like we do have some time for some more questions. All right, so type of refrigerant used. All right, right now we use all R410A.
Yep.
All right.
For those of you who are wondering what we are changing to for the upcoming 2025 refrigerant change, we are going to R32.
All right, so not really a question. The gentleman says he's got a high efficiency dual fuel system in his house and he loves it. Well, I'm glad to hear that. That's awesome. So he's got the high efficiency and the dual fuel. I mean, can you ask for more, right? So retrofit with an oil furnace, like if you're doing a heat pump versus an oil furnace, I believe oil is probably along the same lines as propane when it comes to cost for per therm or BTU or however they measure oil. It's probably along the same lines, right? I mean, would you guys agree with that as far as the energy usage?
I believe it's currently more expensive based on the conversations I had recently in New England. And there are people actually switching over from oil to propane because the propane was cheaper, which that's kind of an odd, strange conversation to have for somebody from Texas where propane's very, very expensive compared to natural gas. So to hear that, it's like, wow. So yeah, that's a great case study to change over to all electric and go with the heat pump, right?
Yeah. Well, and speaking of, I mean, both LP and fuel are linked heavily to the price of oil, and we know how much that changes. Well, as a matter of fact, we have a video on a job in Ohio that was all originally oil, oil burn furnaces and all that, and they switched this funeral home over to all electric, all GREE, muti-pro. And I believe there was a mini split or two on that job as well, and they've saved, I mean, just a ton. We've got a really great video on that on the GREE Comfort YouTube channel. All right, someone is asking if we're going to have a makeover for the Flex outdoor units, if we're going to be moving the valves, like the valve positions, both from inside the outdoor unit and also like on the 4 and 5 ton, they're pretty close to the bottom. If there's going to be moved up, with Justin maybe able to answer that better than I.
Yes, so we worked with the factory on the new versions of the Flex, the Eco, and the Ultra. On the 2 and 3 ton unit, the valves have been moved to the outside, like any other standard mini split. So they're easy to access. You don't have to try to run your copper pipe up inside the casing. And as for the 4 or 5 ton, yeah, we did realize that the valves were really low. So if you weren't putting the unit on some kind of stand or pump ups, if it's just going on the slab, it could be very difficult to get your hoses on there. So we asked the factory to go ahead and move those up, and then also angle them upward at a 45-degree angle to make them much easier to access. So when we release those new iterations of Flex, probably later this year, just be on the lookout for those.
Right. Another question, Justin, I think you can speak to this. Are all of these products going to be a part of the Mass Save approved heat pump list? That kind of brings up another conversation of, maybe dual fuel's not for you in this scenario where, the rebates are requiring the removal of the fossil fuels from the home. Can you speak to that, Justin?
Yeah, it's a great point. So I know Mass Save was mentioned, but that's just one of many state programs or utility programs that are offered for upgrading existing equipment or with high efficiency heat pumps. So basically you'd have to look at your local utility program, see what the requirements are. Generally they're pretty high efficiency. So I don't think with a lot of dual fuel applications, like using a dual fuel with the Flex and our A-coil, the EER is too low. It doesn't get there. So in that type of dual fuel situation, it wouldn't qualify. But in other places like, is it Michigan or Dakota, somewhere up north, in the Midwest, it does qualify for their program locally. So, just take a look at your local program and see what qualifies. We do keep everything kind of updated through, our online eco rebates database, where you can go into our rebates page, type in your zip code, and you can see every unit that will qualify for a rebate in your area. We also work very heavily with the NEEP program in EEP. and we make sure that we keep that database pretty well updated all the time. That way, most of the programs in the Northeast, like Mass Save, they will pull from generally the NEAT database. Others will pull directly from AHI. So we try to keep all that updated. So I can't say that everything will qualify for everything. You just have to look and see what qualifies in your local area. And this rebate page that we have pulled up here is the best place to go and see what does qualify.
Well, that actually answers a couple of the questions that came through when you brought up NEAT and like Energy Star, that kind of thing. On the one question was asking specifically for the flex coil rating and NEAT and Energy Star and those programs. Like you said, to your point, checking our the rebate finder on our on greecopter.com is a great way to find that. And that also goes back to the point that Daniel made, where if they're offering rebates to go all electric and they're not offering it for the dual fuel, then it might make more sense to go all electric, right? Mm-hmm. Because some of these programs are enormous rebates. I mean, just like you can go get a new car while you're at it. Some of them get 3 systems.
On the Mass Save program, we've seen rebates, $10,000. So in those situations where, oh no, I have to upgrade my electrical service to have upgrade the panel to do all the full electrification. Well, there's a big chunk of change right there to go ahead and do that work and get your system upgraded.
Right. Which actually leads to another question. Let's see. Up in the cold rural areas of New York, large homes, stockless bedrooms with heat pumps and all electric mechanical equipment, not having access to enough electric to power the equipment and having to bring in absolutely massive generators to not risk a winter freeze. Does the emerging tech address this in any manner as far as sizing of generators? So I can go ahead and take a whack at that. If you have a cold climate heat pump that's not having to bring on the electric heat in order to provide heat, you are not going to have as large of a generator than you would with a traditional heat pump having to use electric heat, right? If I took a typical system with 15 kilowatts, I'm looking at 90 amps worth of service, right? In total, not mistaken. A heat pump that's capable of providing the heat down to minus 31, for example. If I don't need that electric heat, then I don't need to necessarily bring that electric heat on. Therefore, I could run that on a smaller generator. Smaller gear all the way around, right?
The other thing you got to keep in mind there too is that there is no lock rotor amps, which is hard on generators when you're starting a typical bang on, bang off unit. With a standard compressor, you're going to pull lock rotor amps starting that PSC compressor. When you have an inverter driven unit, they're all soft start. They start out real slow and slowly ramp up. So the generator is going to handle that much better than a standard on off unit.
And a good chunk of our equipment, I mean, all of them are electronically limited. So like in the case of at least a couple of models, the maximum amount of amp draw, for example, out of that unit that it could theoretically produce is going to be about 19 amps. Before it were to shut down on the air code, for example. So I mean, I believe that's something that I would keep in mind if I was trying to size a generator for a system like that. If I'm able to do that. And speaking of strip heat, can you disable the heat strip if it's not needed on the flex? Yes, you can.
Most certainly.
Yeah.
Yes.
If you don't put a heat kit in, that's one way to do it, right? Just not put one in at all. I mean, but
the other way would just don't hook up W.
Don't hook up W, and you don't have electric heat, right? Right.
So one other comment I want to make real quick, and just while I got everybody's attention on this podcast, if y'all haven't seen James, who's just been talking the most lately here, and his video of why GREE, you need to get on YouTube and go to greecomfort.com and pull up that video of why I agree, because bar none, in my opinion, it is the best video anybody I've ever seen technically produce and do. And also it does actually answer why we do what we do in the technical service department. We do actually take this job seriously, and we do really want to help you guys out in the field with the equipment whenever you are having issues with it. So,
Right. I feel like this podcast gives us, gives people a taste about how much we nerd out. These are like regular conversations that we normally have. I mean, it's every day. That we're pulling up that video now. I appreciate the kind words there, Greg. I do call myself a nerd in it. I call us all nerds, but hey, still a positive thing, right?
Hey, we are.
Yeah, that's true.
and what he says in that video, he does say, he's like, there's times that you go to bed at night and you're still thinking about that one unit. And it's like,
Yes.
okay. And believe me, we do. And I know you guys out there servicing and installing and working on these units, you do the same thing as we do. So we haven't lost that, and a lot of us came from the field, and we know where you're coming from, right? So hasn't changed.
Excellent. So, James, do we have any more questions from the audience?
Yes, we do. One is, how much of a difference would you say, right? How much of a difference would you have between keeping an old furnace with a PSC fan motor versus upgrading to a variable speed ECM? How much difference do you think it would make in terms of efficiency dehumidification if you're using like an inverter driven or variable speed system? I would say, in my opinion, it's pretty significant. There's a reason why almost all other inverter driven systems will slow down the fan, that kind of thing.
I would really jump in and say the ductwork, if you're going with a centrally ducted system, the ductwork will make all the difference in the world regarding the efficiency, because we've seen situations where, you don't have enough ductwork and the static pressure is very high. And so changing from a standard PSC motor and going to full variable speed ECM, that variable speed ECM, it's also what we call a constant CFM motor. So it's going to try to ramp up to provide the CFM that's programming the system. And if you have really high static pressure, it's going to try to overcome that static. And in doing so, it's going to use a lot of electricity. So we've seen those situations where people, have really bad ductwork and they replace an old PSC system with variable speed ECM. And because the ductwork's so bad, the energy bill can actually go up. So first and foremost, please look at the ductwork, check the static pressure, and make sure the ductwork is sized properly and it's installed properly. If you're using flex duct, make sure it's pulled nice and tight. You don't have a lot of flex or bends in it. Make sure it's supported properly and that we're getting proper airflow. I can't stress enough how much proper airflow plays into efficiency. Now, that being said, all things being perfect, James is absolutely correct. Going from a PSC motor to variable speed ECM is a world of difference. It can be extremely efficient. That's provided everything that's connected to that unit is installed properly and sized properly.
Well, and it goes to that saying, bad ductwork is an ACM motor killer, and a variable speed motor is not the fix to bad ductwork.
Right. Well, that was my question, because I'm in sales now. I was going to ask if it fixes your bad ductwork.
It does not.
Well, that's it as far as the questions that we've got right now.
Well, we are at the top of the hour here, and so we'll wrap it up, and we appreciate everyone being here. If you please send us the topics on what you want us to cover in the future. I definitely love suggestions from our audience and all of our customers. And Justin, you want to finish up?
Yeah, absolutely. So I want to thank everybody for joining us. I want to thank Greg, our special guest, for being on today and providing a lot of great insight into our dual fuel discussion. And for those of you who haven't been able to make it live, as always, we're going to post this video onto YouTube. So, you can go there and watch it, or if you just want to rewatch it because you love us so much, please do give us some more views. And if you didn't have a chance to ask a question today, or maybe like we said, you're laying there at night and something just pops in your head and you want to ask us a question, even though we're not live, you can go in our YouTube comments and you can leave your question there. And our team's really good about scouring those comments and finding those questions that we can answer. So if you want to ask us anything, feel free to leave that comment on YouTube, or if you can't wait, feel free to reach out to your local GREE dealer or distributor and get in touch with them. So with that, thanks everyone, and we'll see you next time.
Hey, thanks for watching Talking Comfort Live with GREE HVAC. Make sure to keep a lookout for an invite to our next show, or subscribe to our GREE Comfort YouTube channel to make sure you get notified anytime we release new content.